So dear students, now let us move on to dot product. So here, product of two vectors, I think this is 7 plus marks. Am I right? 3 1 marker question, then 4 5 6 7 8. Yeah, fine. I just forgot to mention. So now let us move on to product of two vectors. And from here, our actual vector algebra application starts in three-dimensional geometry. Whatever we have learned is too basic. Now let us proceed. Product of two vectors. We had scalar multiplication. Our vectors multiply by number. But here both are vectors. Now in this, we have got the first one is dot product. Now let us proceed with dot product. Let us go for the definition first. Let vector A be non-zero vector and vector B also be non-zero. So we have a two non-zero vector. Then dot product is denoted by A dot B. See here. If you talk about numbers, no. 3, 7. What is the value? What is the value of 3, 7? Until unless between 3 and 7 I have not given the operation, we cannot perform any operation. If I have given you plus in between, then you say 3 plus 7, 10. If I given minus, then you say minus 4. If I given into, then you say 21. Correct? So the operation between the two numbers should be given. Similarly, between the two vectors, the operation should be given, and the operation is dot product. So this symbol dot. Okay, since we use this symbol dot, we also call as dot product. So for this operation, okay. So is given by A dot B and is defined as vector A dot B is equal to magnitude of the first vector, then the second vector into cos theta. Understand this. In A dot B, A is the first vector, so magnitude of the first vector. B is the second vector, so magnitude of second vector into cos theta. This will be the definition. Where what is theta? Theta is angle between the two vectors, vector A and vector B, and theta is lying between close interval 0 to 5. Okay, so if you take a diagram for this, so vector A is here, vector B is here, and theta is an angle between vector A and vector B. I hope this is clear. Now let us talk some of the important remarks or notes of this. First thing, here we have assumed that both the vectors should be non-zero vector. What if any one of the vector is 0? So remark number 1, if let us suppose vector A is 0 vector or vector B is 0 vector. Let us take a diagram again here. Okay. So this is vector A and this is vector B. And here we have got an angle theta. Why theta is formed? Because these two lines, first lines are there. For that line, if I give arrow mark, then it becomes a vector. So the two vectors are intersecting here. Since they have got some length, so they are able to intersect. Now see, if any one of the vector is 0. For example, vector B is 0. So since vector B is 0, this length should not be there. As soon as I am removing the length of B, it's just a point here. Now there is no angle formed. Nothing but theta is not defined. So if any one of the vector is 0, then theta is undefined. There is no angle. But if you see the dot product, as soon vector B is 0, modulus of vector B will be what? Means magnitude of vector B is what? 0. Because as soon as a vector is 0, its length is 0, magnitude is 0. 0 into any number, cosine is also a number between -1 to 1, close interval, don't forget. So all these are number, both mod A and cos theta are number. So 0 into any number is what? 0. So then we are going to have dot product to be what? 0. If any one of the vector is 0. These all are very important remarks for one marker and also for competitive exams as well. Concept cannot be compromised. So now let us move on to the next remark. See, carefully observe what is A dot B. Definition says it is mod of first vector, then mod of second vector into cos theta. Let us try to understand what is the output of dot product between the two vectors. Which quantity it is? Is it a scalar or a vector quantity? For that, see carefully. Modulus of vector A, the right hand side, if I just see, this is a number, scalar, right? Mod of B is also scalar. What is cos theta? Don't forget cos theta is going to lie between closed interval -1 to 1. This is also scalar. So right hand side is a multiplication of three numbers. That is mod A, mod B and cos theta. So very clearly we can say that A dot B is a scalar quantity. A dot B is a scalar quantity. So the other name for dot product is scalar product. I hope the things is clear why there are two names for this dot product, because of the notation that between A and B we have a dot, and why scalar product, because the output is what? A number. Okay. Now let us move on to the next part. See, now let us take point number 3, and here let us say that both the vectors I will take as non-zero vector. So our entire concentration from here will be both are non-zero vector. If it is a zero vector, what is going to happen? We have already seen. Now since A and B are non-zero vector, and in this, let us suppose first case I will take, let us suppose the angle between the two vectors is 0. 0 degree, both are same. Now let us take this diagram. See, let us try to understand nothing but the diagram. So if I set theta is 0, there is no angle formed. So vector B is here and vector A is here. I hope it's recording. Thank God, it's recording. So if vectors are actually what? Collinear. We are talking about the case of collinear vectors. Now see, if theta is equal to 0 and if I substitute this in equation number 1, we are going to have A dot B is equal to magnitude of A, magnitude of B, and what is cos 0? 1. Let's put here cos 0. Cos 0 is what? 1. So we are going to have A dot B is equal to modulus of A, modulus of B, cos 0 is 1. 1 into this 2 modulus term is same. So whenever we get A dot B is equal to mod A, mod B, what we can infer is the given vectors are collinear vectors. In particular, what? In particular, what is the angle made by a line with itself? 0. So every line, I repeat, what is the angle made by this line with itself? If I have got two lines, there's some angle formed, correct? 90 degree, some acute, obtuse angle. But for a given line, there's no angle formed. Now, since there's no angle formed for this, if I give an arrow mark, it becomes a vector. So what is an angle made by a, what is the angle made by a vector with itself? What is an angle made by a vector with itself? 0. So in particular, if I just put here, what is dot product between the same vector, that is A dot A, it will be what? Mod A into mod A itself. No sir, I don't want to substitute here. I want to get from here. Okay, theta is 0. So here A dot B. So first vector, second vector magnitude. Here it is A dot A. So mod of A, cos 0 is 1. So I'll get base here, both are numbers. If bases are same, we can add the power. Power is what? 1 plus 1 is 2. So mod of A the whole square. So dot product of two same vector will be square of its modulus. Okay. Next point. See, We are taking all the consideration presently on what? These two vectors are non-zero. Okay, third point here. Or third point B. What if theta is equal to pi by 2 radian or theta is equal to 90 degree? Again, if I put in equation number 1. So first let us see the diagram. See this. I have got this diagram. So this is my vector A and this is my vector B. Need not be of same magnitude. But here the important thing is angle is 90 degree or pi by 2 radian. To substitute here. So vector A dot vector B is equal to magnitude of vector A into magnitude of vector B into cos 90. What is cos 90? 0. 0 into any number is what? 0. Very important result. A dot B is 0, not 0 vector. You can see I'm not taking an arrow mark here. Why? We have already understood that dot product is what? Scalar quantity. For scalar quantity, arrow is not mentioned. So here what we have to understand is if the given vectors are non-zero and if you get dot product be 0, it means what? The angle between them is 90 degree, nothing but they are orthogonal. And you should be extra careful. Dot product is 0 here also and here also. As soon as you get dot product to be 0, you cannot comment. You have got actually two conclusions. What? Any one of that is 0. Other conclusion is if you are sure that both the vectors are non-zero, then you can comment that they are orthogonal, perpendicular. So yeah, this implies vector A and B are orthogonal. In place of saying perpendicular, we can also use the word orthogonal. Point number C. What if theta is equal to pi? See, all these cases are happening because A and B are non-zero. Because of that, due to which we can form some angle here. See carefully. See, if this is vector A, surely vector B should be this side. Only then we can have a what? Angle to be pi radian. Let us make it bigger, pi radian. And I hope from the diagrams looking that both the magnitudes are different. Yeah, I have extended vector here to make sure that you understand that lengths are not same. I mean to say they are not negative vector. Need not be. Okay. Now if I substitute in equation number 1, after this I'll discuss a particular case for negative vector also. So if I put theta is equal to pi in equation number 1 again, then what we are going to have? Vector A dot B is equal to magnitude of A, magnitude of B into cos pi. What is cos pi? Recall, cos pi is -1. So it means this value is always -1, due to which we are going to have A dot B is equal to minus into here plus will be minus A magnitude into vector B magnitude. So whenever you see dot product between the two vector is negative of the modulus of vector A and vector B, it means what? The angle between them is what? 180 degree or pi radian. Whereas dot product between the two vectors mod of A mod of B, it means their angle is 0. Actually both are collinear case only, but here it is in negative direction, here it is in the same direction. Okay, now having all this, let's try to move on with the next point. See, here we have discussed A dot B. If in particular, let us take the particular case. In particular, what is going to happen if I talk about there is a vector A here, okay, and here we have, it's looking correct. Oh, okay, for a while I will just erase. I just wanted to have a very good clarity here. See, this is a vector A, okay, and here it is again vector A but in negative direction, so minus here, the angle will be what? Pi. Just see here, this and this both are of same magnitude but directions are opposite. Now what will happen if I take dot product between a vector and its negative vector? Negative vector. So again, recall the dot product definition. Magnitude of first vector and second vector into cos theta, the angle between them. So it is magnitude of the first vector, then magnitude of second vector into cos pi. What is cos pi? Minus 1. So minus to plus will be minus, and here modulus of a. Mod will convert negative to positive. So again modulus of a. Mod of a will be mod of a the whole square vector a dot minus vector a. So a dot minus vector a is negative of modulus of the whole square. Okay, so a dot a is mod of a the whole square, but dot product of vector a and its negative will be what? Minus of mod of a the whole square. Actually this result we can also get from here. Take negative out, scalar we can take out, then a dot is what? Mod of a the whole square with minus sign. Okay, so all the cases we have discussed here. Now let us try to move on to unit vectors, I cap, j cap, k cap. Come on. So this is point number 4 now. Let us consider, let I cap, j cap and k cap be unit vectors along positive x, positive direction, or better positive direction of x, y and z axis respectively. Let us try to have a diagram. Long back when I discussed the component of vectors, I just gave the diagram. So again let us move on with the same. Let's be a straight one. Yeah, this is better. This is our y-axis, x-axis, and here z-axis. Position is here. Along x-axis, which is the unit vector acting I cap. Along y-axis it is j cap, and along z-axis is k cap. These are the unit vectors whose magnitude is 1 and acting along x, y and z-axis. Now let us take the dot product among this. And see, this is our particular case of this a and b are any vectors in this case, but here it is a unit vector along x, y and z axis. So if I talk about dot product between the same vector I dot I, see carefully, I can just use this than doing for this. No, so I want to go for this, then also you can get, but okay, let's go for this. So dot product between the two vectors a and b is mod of a, mod of b. So here also dot product of I cap and j cap will be mod of I cap, then mod of again I cap, because both are I cap here, into cos theta. What is the angle between I cap and I cap? I cap is lying on x axis. What is the angle made by x axis with itself? 0, because it's a single line. Angle made by a line with itself is what? 0. So it is 0. Vector is also 0. I cap is making angle with itself is what? 0 only. Cos 0. Okay, we have got. So what is the I cap magnitude? 1. This I cap magnitude also 1. Cos 0 also 1. 1 into 1 into 1 is what? 1. So I cap dot I cap is what? 1. Which you could have also got from here. If I could have put here, yeah, I dot I is mod of I the whole square. What is mod of I cap? 1, because a unit vector. Now similarly, we can also say that mod of j dot j is 1 and mod of k dot k cap is also 1. Now what will happen if I take dot product between I and j? See, I cap dot j cap. I cap is acting along x axis, which is like this. Since board is 2 dimensional, we have drawn a slant line, and j cap is along y axis. I repeat again, I cap is along x axis, j cap is along y axis. What's the angle between these two? 90 degree. So again, see here is a directly you can comment whenever two vectors are perpendicular, dot product is 0. So I dot j is 0. No sir, I want to comment from here. No problem. I dot j mod of I cap 1, mod of j cap 1. Angle between them is 90 degree. Cos 90 is what? 0. So 1 into 0 is 0. But which we have got here only. So I dot j is 0. Similarly, j dot k cap is also 0. Similarly, k dot I cap is also 0. And not only that, even j dot I cap is also 0. Then k dot j cap is also 0. And k dot I cap is also 0, because again they are what? Perpendicular. So this will be one of the important result for our one marker question as well. Okay, kindly make a note. Let I erase this side. Now let us move on to the next point, point number 5. See, let us recall what is A dot B once. It is magnitude of first vector, then second vector, and then cos theta. When I am talking about this, our vector, if I say vector A is here and vector B is here, I am going from A to B. So it is in anti-clockwise direction. But if I talk about B dot A, nothing but again same diagram, but see carefully. Now I am going from B to A. So B to A, this is clockwise, so it is negative. Don't forget, always anti-clockwise is positive direction, measuring angle, and clockwise is negative. Since it's clockwise, so negative angle here. But come back here in definition, mod of first vector into mod of second vector. So here, first vector is B here, so mod of first vector B and mod of second vector, that is here, into cosine of the angle between the vector B and A. And angle is minus theta. What is cos of minus theta? What is cos of minus theta? It is plus cos theta. So I am going to get this one to be B dot A is equal to mod of B mod of A into cosine of theta only. And if you see with the right hand side, don't forget we took this as equation number 1. I will follow the same. Okay, so mod of A is here, mod of B is here, cos theta. Don't forget, numbers are always commutative. So mod A, mod B, what are those? Real numbers. So this is same as equation number 1, nothing but A dot B. What have we understood from here? Dot product is commutative. This implies that is dot product is commutative. What next? Sixth point. What about the angle between them? So cosine angle. First, if we talk about cosine angle, very simple. From here, solve for cos theta. I can cross multiply this, so I'll get cosine angle to be cos theta is equal to A dot B divided by magnitude of A into magnitude of B. This is the cosine angle. Now let us suppose we want only angle. Then I can take cos inverse both the sides. So theta is equal to cos inverse of A dot B divided by magnitude of A into magnitude of B. Okay, this is the angle between them. I hope this is clear. So this all will be very important for us to proceed with the problems. Now the next question. Okay, first you make a note. Now let us try to list some properties. Yeah, of dot product. First is distributive property. Let us suppose that we have a 3 vectors and it is a vector A dot vector B plus C. We can distribute the dot product over the addition. So it will be A dot B plus A dot C. Yeah, even if you have minus sign here, then there will be a negative sign here. Then coming to the scalar multiplication, let us suppose that we have got vector A dot vector B and one scalar lambda is present. Then this scalar can be multiple to only vector B also. And we can also have that no scalar is completely out. First we can perform. What's the meaning of this? What's the meaning of this? The meaning is either you can multiply the scalar with vector A and then perform the dot product, or multiply the scalar lambda with vector B, then perform the dot product, or first perform the dot product, then multiply the scalar. And here one point to be raised: how to find the dot product? Let's try to make as point number 8. How are we going to find dot product? Very simple. If vector A is A1 I cap plus B1 j cap plus C1 k cap, and vector B is given as B1 I cap. Okay, I will do one thing. This I will take as A1, A2, A3, and this I will take anyway B1 I cap plus B2 j cap plus B3 k cap. Then the dot product A dot B is given as, see, directly let us multiply I with I component, J with J component, K with K component. But what's the reason? Don't forget, we already understood I dot I, J dot J, and K dot K all are equal to what? 1. Whereas I dot J, J dot K, K dot I is equal to 0. Similarly, J dot I is equal to K dot J is equal to I dot K is also equal to what? 0. So just here, we have found dot product I dot I 1 and A1 B1 as it is. Then I dot J 0. No, then A1 into B2 into 0. Then I dot K is also 0. That's what I'm saying, that we are just going to multiply I with I, then J with J, A2 B2 plus A3 B3 because of this reason. So this is A2. So dot product between the two vectors is sum of the multiplication of I with I, J with J, and K with K scalar components. Okay. So kindly make a note. We'll take a last concept, that is projection. Kindly make a note. Now, dear students, let us move on to projection of a vector on a line, the last concept. Projection of a vector on a line. Nothing but shadow. See, I have got a line and there is a vector AB, and I want to find the projection. And suppose this vector is small vector A. Vector AB is small vector A. And if I drop a perpendicular here, let's suppose C here, then the vector AC is vector P. Okay, vector P, let us write a bit more proper. Now I want to find the projection. Now here is an angle theta. So projection is defined as projection of AB on AP. Projection of AB on AC is magnitude of vector AB into cos theta. One question will be there: why it is so that it is cosine only? Simple logic. See, which are the two sides involved? Hypotenuse AB and the adjacent side, adjacent to angle theta AC, which is the trigonometric function which is involved, which is the trigonometric function which will involve the adjacent side and the hypotenuse. It is cosine. Okay, so cos theta is equal to adjacent is AC magnitude divided by AB is the hypotenuse. So we are finding the shadow. So cross multiply, we get this only. So now here some of the important things to be understood. See, the projection which you want to find here, in this particular case, theta, whichever we have got, is lying between 0 to 90 degree, due to which the projection will be along the direction L only. This is case number 1. So it can also happen that L is here, not A is here, B is here. Okay, now even the line is this side now, but now the projection will be what? Here it is, theta, and this time theta is case number 2. Case number 2, this is obtuse. Nothing but theta is between 90 degree to 180 degree, due to which the projection will be opposite to the direction of the line L. Okay, it won't be in this direction, opposite to the line. So it will be in opposite direction. Similarly, opposite. Okay, here it is. Projection will be in the direction of L. Here it is opposite direction. Third one, you see, again the line L, and let us suppose point A is here, B. Okay, this is B, and this is here, right? Now see the angle. This is obtuse, this is reflexive, so it is theta is between 180 to 90 degree. Sorry, 180 to 270 degree, and again it is what? In opposite direction. Last case, the fourth one. Again the line is here, and this is our A and B. The angle is from here to here, and theta is lying between 270 degree to 360 degree, and the projection is in the same direction of the line L. Again P vector is here. Similarly, P vector is here. It is moving in the opposite direction. Again here P vector is here. Okay. Now one more thing to have a note as, okay, as a note we can take, if theta is equal to 90 degree or it is 270 degree, come here, what is cosine? See, for all these cases, mod of AB is same, cos theta is also same. Since in the second quadrant and third quadrant, don't forget ASCC rule. In second and third quadrant, cosine is negative. That's the reason the direction will be opposite. The projection will be opposite to the line L. Whereas this is P. Whereas if it is in first case and the fourth case, since it is in first and fourth quadrant, cosine is positive, so it will be in the same direction as line L. So the expression is same for all. Only this cosine term will decide the direction. Okay. Now, as soon theta is 90 degree or 270 degree, cosine of 270 degree or cosine of 90 degree is 0, due to which projection will be 0. Okay. Next. And as soon as theta is equal to 0, projection of AB same as AC. Similarly here also, as soon theta is equal to 360 degree, projection of this AC and AB will be, length will be same. Now moving on to the last point. See here, if you talk about projection of vector A on P, see carefully. Here, I want to know projection of this. Now, as the definition says, it is vector mod of vector A B into cos theta. See careful, theta is angle between AB and AC. So let's substitute here. What is mod of AB? Vector A, mod. And cosine angle is dot product between the vectors forming the angle. It is AB and AC. So dot product between AB. AB is vector A and AC is vector P, divided by magnitude of vector A and vector P. Let us again try to make you understand. If at all you have got dot product, what is cosine angle? It is dot product of the two vectors divided by its magnitude, correct? No. So what I am saying is, if theta is the angle between vector B and vector A, we have to form the Cosine theta is dot product between the two angles divided by their magnitude. So in place of that, we have got A and P. So it is dot of A dot P divided by magnitude of both. I'm just trying to give a result here. So mod A will get cancelled. So we are going to have vector A dot P divided by magnitude of P. Or I can also say it is A dot P by mod of P will be P cap. Okay, so from here one note what I can write is projection of vector A on vector B is, see, this is the projection of vector A on P. So in place of P it is B. So just replace P by B. So we'll get vector A dot B divided by magnitude of B, or I can also say vector A dot B cap. Similarly, I can also say projection of vector B on vector A is B dot A or A dot B, both are same because dot product is commutative. So I write A dot B itself to avoid confusion. Divided by magnitude of A. Again, this is same as A cap. What is A by vector A? A cap dot vector B. Okay. And how to remember? Very simple. Projection of vector A on B. On whom it is? On B. Whichever on we are taking, that should be in denominator. Here projection of vector A on A. So it's on A. So that should be in denominator. I hope this point is clear. So one point I would like to take here, what will be the projection vector for one marker? Projection vector. Projection vector. Okay, sorry. Projection vector is vector A dot vector A dot B divided by mod B. Correct? Now this will give a projection. It will give only length. See, A dot B is some number divided by mod B. It will give some number. If I want projection vector, no, this should be multiplied by B cap. Should be multiplied by B cap. So why B cap? Since it's on what? Let's try to draw a diagram here. So yeah, see this. Vector A is here, and I want on B. Correct now? Yeah, on B I want. So this shadow I want here. Correct now? So A dot B divided by mod B. Since I want on vector B, so B cap. Now why B cap? Why not only B? If I take the modulus here, B cap mod will be 1. And assume B cap mod is 1, 1 into this is same thing, nothing but I'll get back the result. Okay, the other way of writing this will be A dot B divided by mod of B. What is B cap? Vector B divided by its modulus. Other way of writing, last simplification will be A dot B into vector B divided by mod B into mod B is mod of B the whole square. So all the three are equivalent, actually equal. Okay, so kindly make a note, we are ready for the problems. Okay, now let us take problems on dot product concepts. First I have taken from model question paper number 2, a 1 marker question. As we are aware, this is from academic year 2025 to 2026 by KSEAB. The Karnataka board. Now question says if, actually in the question they are given a mod here, there is a printing error, because if we give a mod here, we cannot have a negative sign here, so I have not taken mod. So A dot B is equal to minus of mod A mod B, then the angle between the vector A and B is, in the remark we discussed, if you remember the answer is pi, but let us solve and get it. A dot B, what is A dot B definition? Mod of A mod of B into cos theta is equal to minus of mod A mod B. Very clearly on either side, mod A will get cancelled, mod B also will get cancelled. So what is remaining? Cos theta is equal to minus 1. Which angle of cosine will give minus 1? Pi radian. So option C is correct. Next, question number 19, again a one marker question of fill in the blanks. The scalar product of these two vectors is minus 10, then what is the value of lambda? Since this is scalar product, so let's take the first vector, lambda I cap plus j cap minus 3k cap. Since this is scalar product, so in between these two vectors, I should give a dot, and the scalar value is minus 10. And here it is 3i cap minus 4j cap plus 7k cap. Now multiply I with I, j with j, k with k. So lambda into 3 will be 3 lambda. Then j cap multiplies 1 here. 1 into minus 4 will be minus 4. Then minus 3 into 7 will be minus 7 is 21 is equal to minus 10. So as you can see, 3 lambda minus 4 minus 21 will be minus 25 is equal to minus 10. Transpose this, we are going to have 3 lambda is equal to 25 minus 10, or 3 lambda is equal to 15, or 3 ones are 3 5s are, lambda is equal to 5. So the value of lambda is 5. Next, a 2 marker question from the same model question paper. The question says find the projection, yes, find the projection of the vector A on this vector B. That's what I gave you the formula as well. So projection of vector A on vector B is given by vector A dot B divided by modulus of B. What is vector A? It's here. It is 2i cap plus 3j cap plus 2k cap dot vector B. Vector B is here. It is I cap plus 2j cap plus k cap divided by mod of B. Nothing but modulus of I cap plus 2j cap plus k cap. How to perform dot product? Multiply I with I, j with j, and k with k. So 2 into I multiplies 1 here, 2 into 1. Then this into is not a cross product, it's a usual multiplication sign. Okay. Then 3 into 2 plus 3 into 2. Then plus 2 into 1 plus 2 into 1 divided by modulus of this. So root of I multiple is 1, so 1 square, plus j multiple is 2, so 2 square, plus k multiple is 1, so 1 square. So 2 ones are 2, 3 twos are 6, 2 ones are 2 divided by root of 1 plus 4 plus 1. So 2 plus 6 is 8, 8 plus 6 is 10 divided by root 6 will be the answer. Now, since denominator is a rational number, we can multiply and divide by root 6 to make it rational. So 10 root 6. Root 6 and root 6 into root 6 is 6. 2 3s are 2 5s are. So final answer 5 root 6 divided by 3. This will be the projection. I hope this point is clear. Kindly make a note. Okay. Dear students, let us move on to model question paper number for a while. Let's check the paper number. Okay. Dear students, it is model question paper number 1. Okay, a 3 marker question. Question says, if vector A, B and C are 3 vectors such that mod of A 3, mod of B 4 and mod of C is 5, and each of the vector is orthogonal, nothing but perpendicular to some of the other 2 vectors, then find modulus of A plus B plus C vector. See, coming to solution, first always try to start with what they have asked. Then you'll understand better how to use the data. See carefully, they said we have to find modulus of a plus b plus c. Take with a square whenever you have got addition or subtraction under the mod. At last step, you can take square root on both the sides. Don't forget, we have already discussed that a mod the whole square. Modulus of a the whole square is a dot a. So whichever vector is inside the modulus, that should be taken dot product. Here we have a plus b plus c, so it is a vector plus b vector plus c dot again with the same. Now here we should understand that other way will be a plus b plus c the whole square. So some faculty gives the marks, some faculty doesn't give the marks, so I don't want to take a risk. I would like to go with the usual procedure where you are getting 3 on 3 definitely. Now see carefully how you are going to perform. Just multiplication. A with a dot is in between, so a dot a. Then plus into plus is plus, then a dot b. Then plus a dot c. Now perform with b dot a. See, when I'm writing here, b and a dot is in between. Okay, so it should be mentioned. Then b dot b, b dot c. So plus b dot b plus b dot c. Next line right here, plus c should be taken with all the 3. So you get c dot a plus c dot b plus c dot c. Don't forget what is a dot a is already mod of a the whole square, and don't forget that a dot b is same as b dot a, nothing but dot product is commutative. So if you see carefully, modulus of a plus b plus c the whole square, which is there in the left hand side, is equal to, see this carefully, a dot a will be mod of a the whole square. Okay, this part done. Next you see b dot b is what? Mod of b the whole square, by using this property. This result done. Okay, property that I'm saying, this result. Then c dot c is mod of c the whole square. What next? Here we have a dot b, and here we have b dot a. So we know that a dot b and b dot a same, and you can see a signs of a dot b and b dot a same. So I can say 2 times of a dot b. Then c b dot c and c dot b, again I can add them, and since it's 2 times, because this c dot b and b dot c same, so I'll give a bracket here, so it will be b dot c. Okay, next a dot c and c dot a. Okay, so again 2 times of this, so 2 is out already, so it will be c dot a. There's a plus sign here, there's an arrow. Just see, for all I given blue dot, as soon as we have solved, yes, we have got the result. See, ABC length is given here, but we don't know the value of this. For this purpose itself, they are given that each vector, how many vectors are there? 3 vectors. So each vector is orthogonal to some of the other 2. Let us use this information. This is our equation number 1. Let us use that information here. So they are saying each vector is perpendicular to some of the other 2. So vector A is perpendicular to some of the other 2 vectors. That's what the meaning of each one vector is orthogonal to some of the other 2. Since we have 3 vectors, A is perpendicular to B plus C. Similarly, vector B is perpendicular to vector C plus A. Similarly, vector C is perpendicular to vector A plus B. Now, let us write in mathematical format. So vector A, see, whenever 2 vectors are perpendicular, dot product should be equal to 0. So dot between A and B plus C should be 0. A dot B plus C should be equal to 0. Again, applying distributive property, A dot B here plus A dot C is equal to 0. Next, Again for this, vector B is perpendicular to vector C plus A. So it dot product should be 0. So again, perform the distributive property here. So here what we are going to have, vector B dot C, vector B dot C plus vector B dot A should be equal to 0. This is also done. Next, here C is perpendicular to A plus B, so vector C dot A plus B is equal to 0. Again performing dot product, so vector C dot A plus vector C dot B is equal to what? 0. Okay. Now, if I take this as equation number 2, then 3, and then 4, let's add them. When I say add left with left and right with right. So add 2, 3, and 4. When I do so, A dot B plus B dot A, both are same. So it is 2 times of, as you know, it is commutative, already we have mentioned, A dot B same as B dot A. So A dot B, let's take it, then B dot A is same, so 2 times of what? A dot B plus, see this, B dot C and C dot B is also same, so if I add, I'll get B dot C, then plus A dot C and C dot A, I can add, so I'll get C dot A is equal to 0 plus 0 plus 0 is what? 0. This I will take as equation number 5. So from equation number 5, I can say that this is 2, mind it, 2 times of, it's not power. So 2 times of this entire value from equation number 5 is what? 0. So I can substitute here 0. Mod of A is 3, so I can substitute here 3 square, plus mod of B is 4, so 4 square, plus mod of C is 5, so 5 square. 3 square is 9, 4 square is 16, 5 square is 25, plus 0. Add this, we are going to get 50. Let's add it here, 50. And the left hand side is mod of A plus B plus C the whole square. But in the question they wanted only A plus B plus C. We have taken the square. So now we can take square root on the both the sides. So we will get A plus B plus C is equal to root of 50. Root of 50 is same as 2 into 25. Root of 25 is 5. Root 2 will be the value of modulus of A plus B plus C. So this will be the value 5 root 2. Okay. This is not a working column. This also carries marks. Okay. Make sure have everything. Means write on everything. Fine. So this is the solution. Job done. Kindly make a note. Okay. Dear students, let us move on to the last problem on dot product concept from model question paper number 3. So, yeah. Model question paper number 3. Question says the projection of the vector A on y-axis is, see, usually we have projection of one vector on the other another, but when I give the concept, it was projection of a vector on a line, and here the line is y-axis. Now try to recall what is the direction cosine of y-axis. We have to recall this. For this recall, we know that the relationship between direction cosines are L square plus M square plus N square is equal to 1. On y-axis, the point is of the form 0, y, 0. Nothing but L, M and N. So here L is 0. M we can say as y, or I can keep as M itself, no problem. And N is anyway 0. Okay, 0 square 0 is equal to 1. Or M square is equal to 1, or M is equal to plus or minus 1. since we'll usually take positive part of y-axis in all our concept in this chapter, so m is equal to 1. M equal to minus 1 will be for negative part of y-axis. Okay, so now the solution will be, see carefully. So from here we also came to know the direction cosine. Direction cosine of y-axis is 0, 1, 0. Okay, now let us go for projection. Projection of vector A on B. So I'll take this part to be vector B. So divided by mod of B. So from here vector B will be what? 0 I cap plus 1 j cap is 1, then 0 k cap. This is for I multiple, j multiple, k multiple, but the scalar components. Vector A is here I cap minus 2 j cap plus 2 k cap dot of vector B. Vector B is here 0 I cap plus j cap plus 0 k cap divided by modulus of 0 I cap plus j cap plus 0 k cap. Now let's perform dot product. Multiply I with I, j with j, k with k. So 1 into 0 is 0. Minus 2 into 1 will be minus 2. 2 into 1, 2 into 0 will be what? 0. Divided by, okay, for this root of 0 square plus j multiple is 1, so 1 square, k multiple is 0, so 0 square. So 0 minus 2 plus 0 will be minus 2, divided by root of this will be 0 square plus 1 square plus 0 square will be 1. So the projection will be negative 2. So fill in the blanks question. So minus 2 is the answer. Kindly make a note. Now we start with cross product, the last concept. And mind it, it's a 1 marker question. Okay, kindly make a note. Okay, dear students, now let us move on to the next concept, that is cross product. So let us define what is cross product. The definition. Listen carefully, pay attention, concepts are really important. Let vector A be non-zero vector and B also be a non-zero vector. Let it be 2 vector. Then cross product is denoted by A cross B and is defined as A cross B is equal to magnitude of the first vector followed by magnitude of the second vector into sine theta into n cap, where theta is angle between the two vectors, vector A and vector B. And what is n cap? N cap is a unit vector perpendicular to both the vectors A and B. Let us understand with the help of a diagram. See, we have got two vectors, vector A here and here vector B, and we have a n cap. This is perpendicular. This vector n cap is perpendicular to both vector A and vector B, and theta is the angle between them. Okay. Now, many will be thinking, no, that sir, it's not looking like, see, it's not looking perpendicular to both A and B. See carefully, and I make you understand. Don't forget, we are dealing with 3 dimension and we are trying to explain in two dimension. This is 2D, correct? But we want to explain 3D in 2D, the board. See this carefully to make you understand. See this. We have got this is vector A, this is vector B, correct? Now I'm going to keep a, this is our end cap. Now see, what's the angle between them? 90 degree, correct? That's what we are saying. So even if I tilt also, now you can see, yeah, it is 90 degree, okay? Fine. So vector A cross B is equal to modulus of A modulus of B sin theta into n cap. Again, theta is going to lie between 0 to pi. Now let us try to go for the same thing, whatever we went for, dot, note or remark, whatever, remark or note. See carefully. The first one, see here we have assumed that both the vectors should be non-zero. I'll take that equation number 1. Let us suppose if any one of the vector is 0, if vector A is 0 or vector B is 0, then what's going to happen? Again, I will take it here. And one more thing before I forget, see we have one more unit vector here. Okay, that is minus n cap. It's opposite to n cap, so it is minus n cap. So there are totally two unit vector perpendicular to both A and B. So if A and B are two, okay, any one of them are 0 vector, then again see this. If I just take the diagram, only if I talk about vector A and vector B, there is an angle theta here. If any one of them is 0, for example, vector A is 0. So if vector A is 0, there should not be any length here, correct? When there is no length here, there is no angle formed. Then theta is not defined. Then theta is undefined. Again, if theta is undefined, since if you have taken A to be 0, so mod of A will be 0. 0 into anything is what? 0. So you get, see, this is a scalar, this is a vector. So don't forget, when you multiply a scalar, this entire thing is a scalar. When you multiply a scalar by a vector, the output is what? Vector only. Then theta is not defined, and we are going to have A cross B to be what? 0 vector, because this entire thing is 0. 0 into n cap will be 0 vector. If any one of the vector is what? 0. Cross product will be what? 0. Now let us proceed the same way. If I am going to assume that both the vectors A is non-zero and B is also non-zero vector, then let us take one by one the cases. Here we are assuming that same like dot product, but that both the vectors are non-zero. Before that, wait. Before I take this one, no. Before I take this, see carefully. See carefully. See here. What is A cross B? A cross B is mod of A, mod of B into sin theta into n cap. As I was just saying that mod A, mod B and sin theta is what? Scalar quantity, a number, a scalar. When you multiply scalar to a number, the output is again what? A vector. I repeat, when you multiply scalar to a vector, the output is a vector. So A cross B will be a vector quantity. Not only that, see this carefully, you listen. Pay attention. See this. As I just discussed about n cap, when I was explaining about this diagram, see vector A is this, vector B is this. Let us assume that this is a unit vector n cap whose magnitude is 1. So I have kept like this. Correct? So you can, this is your n cap, this is your vector A, this is your vector B. I can revert in the, all can see, no? Yes. We can take it down. When I take it down, the direction is opposite compared to this vector n cap. So this is a minus n cap. That's what I have shown here. Okay? Now listen carefully. What is the angle between this vector A, vector B, and with this is 90 degree. This is making 90 degree with both vector A and vector B. Now see this. If I am going to decrease the length, if I am going to, it's visible, no? Yes. If I am going to decrease the length, if I am going to decrease the length, again it is what? Perpendicular only. Length is changing. Length is decreasing now. It's not 1, it's less than 1, but again it's perpendicular, perpendicular, perpendicular. Similarly, if I increase the length, again it's what? Perpendicular only. Correct? I am a bit doubtful. First, I hope this is clear that it is again perpendicular. I am a bit doubtful that when I am explaining this, I didn't saw the camera whether this is visible or not, because when I'm keeping this height, I can see that it's not visible in the camera. So again, let I repeat only for this part. Okay. See, I am saying that n cap is perpendicular to A and B. So it is nowhere looking like perpendicular to A and B. So what I am saying is just see this. Here I have got vector A, vector B. Now this is your unit vector n cap, and I am keeping it here. Now you can see, no, it is perpendicular. Correct? See, whatever way I tilt, it is what? Perpendicular. Since we are dealing with 3 dimension, but we are working in 2 dimension board, so it's a bit difficult for us to explain like this. So live, okay, practically I'm showing. I hope this point is clear. Now whether it is here or below, both times what? Perpendicular. This is your n cap and this is your minus n cap. That's what I showed here, n cap and minus n cap. So we have totally 2 unit vectors perpendicular to both A and B. There is n cap and minus n cap. Shortly I'll be giving the expression also after I explain this. So now what I was saying is that after I have made you understand that if I am going to decrease the length of this n cap or increase the length of this n cap, still it remains what? Perpendicular to both A and B. I hope this point is clear. Just see this. This is A, this is B. This is 90 degree, making an angle with A and B. If I increase the length also 90 degree. If I decrease the length also, it's what? 90 degree. I hope this point is clear. Correct? So now having this point, so I can say that this implies A cross B is a vector perpendicular to both vector A and vector B. Okay. So whenever they ask you to find a vector perpendicular to both A and B, it is A cross B. You should not get confused. So in dot product, you have got A dot B is equal to 0. There no, vector A and vector B are already perpendicular. What? They are already perpendicular, and you have to verify are they perpendicular or not. I repeat, let us suppose 2 vectors are given to you. Okay, I repeat again. If 2 vectors are given to you and they are asking you to check or prove that it is perpendicular, then you have to only perform the dot product. If dot product of those 2 vectors are equal to 0, then it is perpendicular. If it is not equal to 0, it's not perpendicular. Okay. Whereas here 2 vectors are given to you, you have to find a vector. A and B is given to you. You have to find such a vector which is perpendicular to both of this. Then you have to find A cross B. I hope this point is clear. When you want to find a vector perpendicular to both A and B, A cross B. When you have already been given and they are asking to prove or verify that it is perpendicular, then you have to take dot product and equal, and you should get equal to 0. Okay. Fine. So A cross B is a vector perpendicular to both A and B. And let us try to understand what will be the expression. Okay, A cross B have got. Fine, let's go one by one. Now, third point. We are saying it's a unit vector, right? We have got 2 unit vectors, n cap and minus n cap. So, let us mention that there are 2 unit vectors perpendicular to both vector A and vector B given by, see this, n cap is given by, since A cross B is a vector perpendicular to both A and B, so let A cross B here. Now since I want unit vector, divide by its magnitude. Divide by its magnitude. That will give you n cap. So A cross B divided by mod of A cross B. And one more unit vector is minus n cap. Now, so multiply both the side by negative. So what I'll get? Minus of A cross B. As soon as you give minus sign, you'll get the negative vector. Or you can write B cross here, which will come to know that it is anti-commutative bit later. Okay. Bracket is this. Now, this is our unit vectors. We have totally how many? two unit vectors perpendicular to both A and B. Now the question is, how many vectors do we have perpendicular to A and B which are not unit vector? We have infinitely many. So how can you say that? Very simple. See, as I just explained that there is A and B here. As soon as I keep here, this is n cap. So I can make it other than 1 unit also, no? So if I reduce, small, see, here I got so many. So infinitely many. Similarly, I can increase the length also. Infinitely many. I can just keep one above these so many markers and below also. Okay. So we have infinitely many, and it is given by what? Let us discuss. So there are infinitely many vectors perpendicular to vector A and B given by lambda times of A cross B, where lambda is not equal to 0. Nothing but lambda is any real number other than 0. Okay. So as soon lambda is 1 divided by A cross B, I'll get n cap. Lambda is minus 1 divided by A cross B, I'll get minus n cap. Okay. Now let us take the case. So one thing is very clear, that cross product is a vector quantity. So the other name for cross product is vector product. Okay. Now let us take the case where it is what? Non-zero vectors. Fifth point, if vector A is non-zero vector and vector B is also non-zero vector. Okay, obviously here the cases A and B are non-zero vectors. Okay, and here whether A and B are 0 or non-zero, we are going to have always what? A vector quantity. But as soon A and B are non-zero, we'll have a perpendicular vector. Okay, fine. So for this case, whatever I'm talking about perpendicular, both A and B should be what? Non-zero vector only. Okay, so let's mention that also. Here for this thing, vector A should be non-zero vector and vector B should be also non-zero vector. For this also same thing. Now I'm trying to explicitly writing this and try to understand if vector A and B are non-zero, what are the things we are going to see. First one, if theta is equal to 0, nothing but vectors are collinear vectors. Theta equals to what? Collinear vectors, nothing but parallel. If theta is equal to 0, if I put in equation number 1, our equation number 1 is here, theta is equal to 0, sin 0 is 0. So I get A cross B. That is right properly. A cross B is equal to sin 0 is 0. 0 into mod A into mod B will be 0. So I'll get 0 into anything is 0. So 0 vector. So whenever two vectors are non-zero and if it is collinear, then the cross product is again 0. Here also we got cross product to be 0, but here vector A or vector B are 0. Same like our dot product. No, there if any two vectors are 0, dot product is 0, and if any two and if both the vectors are non-zero, dot product is 0. It means they are perpendicular. Here if any one of the vector is 0 vector, cross product will be 0 vector, and if both the vectors are non-zero, then the cross product is 0. It implies they are collinear vectors. What I'm trying to say is, as soon as you get cross product to be equal to 0, you have got two comments. Either any one of the vectors is 0, or if you are sure that both the vectors are non-zero, then they are collinear vectors. In particular, if I talk about A cross A, what is the angle made by a vector with itself? 0. So I will get A cross A to be what? 0 vector only. So cross product between the same vector is always what? 0. There A dot A was mod of A the whole square. Okay. Point B. What if I take theta to be equal to 90 degree pi by 2 radian, or theta is equal to 90 degree? Put here in equation number 1. what we are going to have? Sine 90 to be 1. So I'll get A cross B is equal to mod A mod B. Sine 90 is 1 into n cap. So we are going to have, whenever there is no sign is missing, doesn't mean that question is wrong or the data is incomplete. The angle between them is 1. Let's mention that here sine 90 degree is 1. Similarly here also sine 0 is 0. Next, point C. If the angle between them is pi, nothing but, and this, yes, as soon as I said collinear, yeah, vector A is here and vector B is here. So whenever it is collinear, cross product can be 0. Similarly, if I have got a vector A here and there is a vector B here and the angle between them is pi. So if I put theta is equal to pi in equation number 1, that is here. So A cross B is equal to what we are going to have. Hope it's recording. Yeah, it's recording. Always I'll forget. I'll have a doubt. Mod A mod B as it is. Sine pi. What is sine pi? 0. 0 into anything is 0. 0 into vector is what? 0 vector. In particular, what I can say? In particular, cross product between a vector and its negative vector is again 0 only. Why, sir? See this? If this is a vector A, then this is what? Minus vector A. And this angle is pi. Okay. So angle between, means cross product between a vector and its negative vector is what? 0 vector. I hope it's visible properly. And I check the camera once. -1. Wait for a while. This minus is not looking so good. But I will rewrite that again. It's not looking so good in camera. Let the hard work not go in vain for a while. And then make some space for you all. Means here, so that you can see. So here, what I'm saying is that if this is, and here, I'll write it here. If this is vector A, this is minus vector A. So the angle is what? Pi. Okay, it's already done there. So what is vector A cross minus vector A? Angle is theta equal to pi. What is sine pi here? 0. 0 into anything is 0. 0 into vector is 0 vector. Okay. Reason for this is sine pi radian is 0. So cross product between a vector and its negative vector is also what? 0. Okay. Kindly make a note. Now, dear students, let us move on to next point. See, let's recall just now what we have about cross product. It's A cross B is equal to mod of A mod of B into sine theta into n cap. Okay, and see, we had here vector A, vector B, and there is n cap, and this is the angle theta. This we call right hand system. Okay, now see carefully. I was going from A to B, so it is anti-clockwise. Anti-clockwise is always positive direction. Now if I go with B cross A, then see, first vector mod, second vector mod. So first vector is B here, so mod B. Then second vector is mod A. Now if I take the diagram for this, Now I'm coming in what? Clockwise direction. So minus theta, this is B and this is A. Okay. So now the angle is in clockwise direction. Clockwise always what? Negative direction. So sine of minus theta and then n cap. What is sine of, okay, n cap is somewhere here. Okay. Sine of minus the, what is sine of minus theta? It is minus sine theta. So this negative will come out. So we are going to have B cross A is equal to, this must comes out, so minus of mod B mod A sine theta into n cap. This is sine theta, mind it. Now see carefully. Since we have regarded previously this as equation number 1, I will retain this as equation number 1 only. So if you see this part, which I am highlighting, mod B, yeah, mod B, mod A, yeah, mod B, mod A, mod A, mod A, sine theta, n cap. So what I mean to say is, this is anyway scalar, it is always commutative, sine theta and n cap is same as this. So from equation number 1, I can write this one as minus as it is A cross B, A cross B, and this is B cross A, or I can also write A cross B is equal to minus of B cross A. What's the meaning of this? It is non-commutative, or I can say anti-commutative. Anti-commutative means both are same but signs are opposite. If at all these two should be equal, then for B cross A I should give a negative sign, only then both will be what? Same. So this implies cross product is anti-commutative. Okay. Next, now let us consider the unit vectors I cap, j cap, k cap, which we considered for dot product. So let I cap, j cap and k cap be 3 unit vectors acting along positive direction of x, y and z axis respectively. Three unit vectors acting along positive direction of x, y and z axis respectively. Okay, and I erase that side. Okay, dear students, I have written this one as it is so that we can have a talk about this. Let us have the recording now. Let us have the unit vectors diagram here. So as we know that this is our y-axis, this is the z-axis, and this is x-axis. So along x-axis we have got the unit vector I cap, along y-axis j cap, and along z-axis k cap. Okay. Now I want to discuss cross product between the vectors. If I consider cross product of the same vector, recall cross product between the same vector is always 0. This is a general vector and this is a particular vector. So directly without commenting much, I can just say it is 0 vector. Similarly, j cross j is also 0, as well as k cross k cap is also 0. No, sir, I want to understand from here. Very simple. Angle between the same vector will be what? 0. Sine 0 is 0. 0 into anything is what? 0 vector. Because 0 into any vector is what? 0 vector. So this is the first important. Whereas coming to dot product, I dot I, j dot j and k dot k cap was 1. Next, what about I cross j? Now these are not two. What? This is not same vectors. Now if I apply this definition, A cross B is equal to mod of those two vectors, which are vector present here. So here it is I and j, so mod of I cap then mod of j cap into sine of theta is angle between them. What is the angle between I cap and j cap? Don't forget is 90 degree, because x-axis and y-axis are mutually perpendicular, and I cap is lying on x-axis, j cap is lying on y-axis. Therefore, the angle between I cap and j cap is what? 90 degree. So sine 90 degree. Now listen carefully. What was n cap? N cap is a unit vector perpendicular to given two vectors. Now you see, this is your y-axis, this is our x-axis, which is a vector. This is I cap, okay? This side, this what is coming, the marker is I cap, this is your j cap, which is a vector, unit vector, perpendicular to both this x-axis and means I cap and j cap, it is k cap. So I write here k cap. Is this point clear? In place of n cap, k cap came because k cap is perpendicular to both j cap and I cap. Now what is I cap? Modulus 1. J cap modulus also 1. Sin n is also 1 into k cap. So answer is 1 into 1 into 1 into k cap is k cap. And this is I cross j. So cross product between I and j cap is k cap. Similarly, we can go for remaining. So again, in place of going further, I'll give you an easy way. Now you will erase this. Now it's not required. I hope you have. Anyway, it's required session. You can again rewind and make a note. Concept I have not compromised, nor the problem from the model papers. Now see carefully. Now for this to remember, I'll give an easy logic. Take one circle. Here, let us give the direction in anti-clockwise direction. Here it is I cap, here it is j cap, and here it is k cap. So see, I to j. So when I'm going to go for I to j, which I said is anti-clockwise is always positive, clockwise is always negative. So when I'm going to go from I to j, it's anti-clockwise. So if I close I and j, remains k. So far I got k cap. Similarly, if I go for j cross k, see, j to k, when I go again is anti-clockwise, close j and k, remains what? I cap. So I can write I cap. Similarly, if I go for k to I, again k to I is what? Anti-clockwise. So k to I cap is anti-clockwise. If I close this, I get j cap. Similarly, here it was also j to k is also anti-clockwise. So I got plus I cap. And I to j also was anti-clockwise. J to k was also anti-clockwise. So I got positive. Now, if I talk about j cross what? I cap. J to I, from here to here. What? Clockwise. When I go clockwise, close this, remains k. And since it's clockwise, so I should give negative. And here also no, we call cross product is anti-commutative. I cross j, when I got k cap, surely j cross I should be what? Minus k cap. Similarly, but I'm giving you this way also to remember. So similarly, k cross j cap will be minus I cap. Then I cap cross k cap will be minus j cap, which you can see from here. See, k to j. Yeah, k to j. This is what? Clockwise. So close this, minus I cap again. I and k. I to k. Again it is what? Clockwise. Close this, I get minus j cap. So these are very important results. Okay, moving on to the next. 6th is over, 7th over, 8th. Now sine angle. Coming to the sine angle between the vector, it will be solved just for sine. Now see, to sine angle, no, just see this. Mod of a cross b is equal to mod a into mod b into sine theta into n cap. Sine is a scalar quantity. Its ranges, whose range is -1 to 1 closed interval. But we have got n cap. To find sine angle, we are going to take modulus. Sorry, this is a cross b. Yeah. Now to take sine angle, since it's a sine is a scalar quantity, but here got vector and here also vector. So what we'll do, we'll take a modulus. When I take the modulus, n cap mod, when I take it is what? 1. One question will be coming, why for sine we have not taken mod? Don't forget sine is between 0 to pi. between 0 to pi, sign lies in first quadrant and second quadrant. In first and second quadrant, sign is always positive. So now I take mod. So now what we are going to have? Cross multiply this. So sine theta is equal to modulus of A cross B divided by mod A into mod B. Sine angle. First, kindly make a note of this. And one more thing, since we are going from B to A, this should be in negative direction. Okay, yeah, in negative. Okay, fine. Okay, now let us move on to the next point. Recording, no? Yeah. Next is area of a triangle. Area of triangle ABC. See, let us say that we have a triangle A, B, C are the vertices, and I want to find the area of this. See, if I just drop a perpendicular here and there's an angle theta, recall from school days, if I say that this and this two adjacent sides are there, this is vector A and this is vector B. So there are two adjacent sides represented by the vector. So the area of the triangle ABC from the half of base is BC, and what's the height? AD. Okay. Now base BC is vector A. Fine. What about AD? See, I know the information that I have got two adjacent sides represented by vector A and B. So in this right angle triangle, that is ABD, what will be sine theta? So why only sine theta? See this carefully. I want to utilize, see, I have got AD, this length I know, and I want to use this information. This information I have already used. So which is the trigonometric function which can take care of opposite to theta and the hypotenuse? It is sine theta or cosecant theta. So sine theta, if I take, is what? Opposite is AD. And what's hypotenuse? BA. Now if I substitute here, simplify, cross multiply, therefore I get modulus of AD is equal to BA magnitude into sine theta. But what is BA? BA is mod B into sine theta. This is the value of modulus of AD. Let us substitute this. So it is modulus of B into sine theta. Now just see carefully this. Is it not this is modulus of A cross B? What is mod of A cross B? Mod A, mod B into sine theta. N cap is 1 since I taken mod. Correct? So yeah, both are same. So I can just write half as it is, and this entire thing is same as present here. So it is mod of from right to left. It is what? Mod of A cross B. So this will be the area of triangle. Area of triangle ABC is half of mod A cross B, where vector A and vector B represents two adjacent sides of the triangle ABC. That's what you can say, two adjacent sides. Actually, triangle, no. As soon you take one particular side, the other two sides are what? Adjacent side only. Okay. So if I take this one, then it's our adjacent. Okay. Now the 10th point, area of parallelogram or area of rectangle, both are going to have the same formula. See carefully. Area of parallelogram are here. See the diagram. Let us say that I've got a parallelogram here, and this is A, this is B, this is C, and this is D. Again, I've got two adjacent sides of the parallelogram. Let us suppose this is the A, vector A, and this is vector B. Now I want to find area of the parallelogram, and it is from here. D, if I drop a perpendicular and altitude here, and let us suppose here it is some E. So the area of the parallelogram will be AB into DE. AB mod into DE. Now coming to this, again if I take a angle theta here, again we have a right angle triangle, correct? Now coming to this right angle triangle, see again same scenario what we have taken here also. So in right angle triangle, what is that? ADE. Again I want to use this information and this information, again which trigonometric function sine. So what will be sine theta? It is opposite. Okay, let's say DE here. DE or ED, both are okay, fine, no problem. So I'll take DE only. So modulus of DE divided by this arrow mark is down. Divided by hypotenuse is what? AD. This is D. AD. Again, if I cross multiply this, we will get DE magnitude is equal to AD magnitude into sine theta. What is AD magnitude? AD is mod of B into sine theta. This is DE mod. So I can just substitute here that what is DE mod B into sine theta, and what is AB mod A, and this is what is D mod B into sine theta, and what is this? Again it's A cross B. So area of the parallelogram is modulus of A cross B. Let's write here area of parallelogram A, B, C, D, or even for rectangle same formula, area of rectangle. Yes, now let us take some properties on cross product. Let us list it out here only. Before that, how are you going to find cross product between the two vectors? We're talking about cross product, but how are you going to find if components are given? So just take as a 11th point, if vector A is given as A1 I cap plus A2 j cap plus A3 k cap, and what next? Vector B is given as B1 I cap plus B2 j cap plus B3 k cap. Then the cross product is given by determinant of what? Determinant of first row is I cap, j cap, k cap. Second row is scalar component of the first vector A. What is the scalar component of vector A? A1, A2, A3. A1, A2, A3. Third row is scalar component of vector B. What is that? B1, B2, B3. B1, B2, B3. And we know how to evaluate determinants. Okay. Now, let I also make a note here only about the properties of cross product. Some properties here. First one, it is again distributive. I mean to say, what the way we had A cross A dot B plus C. Here also same thing. Vector A cross B plus C. I mean to say B plus C is same as A cross B. You can just first take multiple here, then here. We can distribute them. A cross C. So this is distributive property. Next, that lambda, the scalar, multiple to A taken cross with B is same as vector A cross with lambda times of vector B. It can be taken with B, so lambda can be with A or with B, or lambda can be out. First you can take the cross product. So where what is lambda? Lambda is any real number. So what's the meaning here? When you want to perform cross product, either you can first multiply scalar with first vector A, then take cross product, or multiply with second vector, then take cross product, or first take the cross product and then multiply scalar. All are same. So with this, all the concepts are done. Now we are just pending with problems. Let's take that. Okay, dear students, let us move on to the problems. This is from model question paper number 1 for 2 marker. As you know, it is for the your academic year 2025 to 2026, issued by the P word KSEAB. Okay. So questions is find the area of the parallelogram whose adjacent sides are given by the vectors. These are the two vectors given. Adjacent sides are given. So recall the formula. If adjacent sides of parallelograms are given as a vector, then the area of the parallelogram is given by area of the parallelogram is given by modulus of magnitude of A cross B it is. First, let us find A cross B. It is determinant of first row I cap, J cap, K cap. Second row is component of first vector A, that is 3, 1, 4. Yeah, see, there is no multiple for J. It means what? 1 into J is what? J cap. Okay, and here it is 1 minus 1, 1. Now expand this. When we are going to expand, we are going to have plus, minus, plus. So plus I cap, leave the first row and first column. Then we are going to have, when you leave first row and first column where the element I cap is present, we will get 1, 4, minus 1, 1. Then minus into plus is minus J cap. Leave the first row and the second column, 3, 4, 1, 1. 3, 4, 1, 1. Then plus K cap. Leave the first one, third column, 3, 1, 1, minus 1. 3, 1, 1, minus 1. So plus minus, plus minus, plus minus. So I cap off. Now let's multiply. 1 into 1, 1. Then minus minus plus, 4 ones are 4. Then minus J cap. 3 ones are 3. Minus to plus is minus 4. And plus K cap off. 1 into, that means plus 3 into minus 1 is minus 3. Then minus 1 into 1 is minus 1. So we'll get here 5 I cap. 3 minus 1 is minus 1. Minus 1 is plus J cap. Correct? No. 3 minus 4 is minus 1. Minus 2 minus is plus J cap. Minus 3 minus 1 is minus 4. Minus 2 plus is minus 4 K cap. This is vector A cross B. Now what we have to find? See here, we want magnitude. As we want the area here. So A cross B will be square root of 5 square, then plus 1 square, then plus minus 4 square. This will be 25 plus 1 plus 16. 25 plus 1 is 26. 26 plus 16, 6, 6, 12. 3, 4, yeah, root of 42. And since it's the area, square units. Okay. Now come to the model question paper number 2, a 1 marker question. Questions is on 2 statements. Statement number 1. Okay, so multiple choice question. If either vector A is of 0 magnitude or vector B is of 0 magnitude, then A dot B is 0. Yeah, this is true. We have discussed in the concept of dot product that if any one of the vector is 0, then dot product is 0 because theta is undefined. Let's recall that. See here, what is A dot B? It is what? Mod A mod B into cos theta. If any one is 0, then what happened? If any one is 0, 0 anything is what? 0. And the angle theta is not defined. That's what we got here. True. Whereas if A cross B is 0 vector, then A is perpendicular to B. No. If cross product of two vectors is 0 and those two vectors are non-zero, then from this we can infer that vector A is parallel to vector B. They are collinear, but they are given perpendicular. This will be true if the two vectors which are non-zero, their dot product is 0, okay, not cross product. Therefore, this is false. So the answer is true. Statement 1 is true and statement 2 is false. That's option A. Option A is correct. Kindly make a note. Okay, yes, dear students, let us move on to the last two questions of this chapter from the model question paper. Question here from model question paper number 3, 2-marker question. Question number 27 says, find the area of the triangle whose adjacent sides are determined by the vectors. Recall what is the formula to find area of triangle, let us suppose ABC. If two adjacent sides are given, it is half of modulus of A cross B. And they say very clearly two adjacent sides are given. So vector A, if you see vector A, I component is there, K component is there, but there is no J component, so it is 0 there. Correct? And vector B is anyway given here. So let us first find A cross B. It is determinant of I cap, J cap, K cap. Now second row is component of first vector, that is -2, 0, -5. Third row is component of second vector, that is B, that is 1, -2, -1. Now let us expand this. If I'm going to expand this, that is plus here, minus here, and plus. So how we are going to get this? Plus I cap. Leave the first row and first column, so you'll get 0, -5, -2, -1. Then minus J cap, again leave the first row and second column, -2, -5. Then followed by 1, -1. Lastly plus K cap, leave the first row and the third column, -2, 0, 1, -2. So let's simplify this. I cap, as you know, it is plus minus here, again plus minus, evaluation of 2 cross 2 determinant. So cross multiplication here, I cap of 0 into -1 will be 0, then minus plus into minus 2 into 5 will be 10, then minus J cap of, again cross multiply, plus into minus to minus is plus, 2 ones are 2, then minus to minus plus, 5 ones are 5, then plus K cap of, plus into minus to minus plus, so 2 twos are 4, then plus into minus is minus, 1 zeros are 0, so 0 minus 10 will be -10, 2 plus 5 will be 7, 4 minus 0 is 4, so we are going to have minus 10 I cap, minus 7 J cap, and plus 4 K cap. Don't forget, we want to find area of the triangle, out of which we have got only A cross B. We have to find mod of A cross B. So this is our A cross B vector, cross product of the vector A and B. Now we want to go ahead with finding the magnitude. Fine, let's find the magnitude of this. Mod of A cross B is equal to square root of I multiple minus 10 square, then plus minus 7 square, then plus 4 square. Now on simplification we will have minus 10 square will be 100, minus 7 whole square will be 49, okay, and then plus 4 square will be 16. So now simplify for 49 plus 16. As you can see here, it is 65. So plus 100 will be root of 165. Can you further simplify 165? Check it out. By 5 table. 5 3s are 15. Borrow 1. 5 3s are 15. Yeah, that's it. Again, if you simplify, you are going to get here 3 11s are. So all are, there is no perfect square number we are getting. So this is our value for root of, means value of mod of A cross B. So therefore mod of A cross B, we have got root of 165. Substitute in equation number 1. If you substitute in equation number 1, we are going to have, therefore area of the triangle is, area of triangle ABC is equal to root of 165 divided by 2. Correct? So root of 165 divided by 2 square units. So this is the end of the problem. Now let us take the last problem, question number 36. Kindly make a note of this. Dear students, let's move on to the last problem from model question paper number 2. Okay, issued by KSEAB. Question says, find the unit vector perpendicular to each of the vectors a plus b and a minus b, where vector a and b are given as follows. Recording, no? Yeah. So see, coming to the solution part of this, since I want a unit vector perpendicular to a plus b and a minus b, recall a vector perpendicular to a and b is cross product of a and b. I repeat, a vector perpendicular to both vector a and b is what? Cross product. And if I want unit vector, divide by its modulus. Okay. Now since I want a vector perpendicular to a and b, I should take cross product of that. Now here I want to find a unit vector perpendicular to both a plus b and a minus b. Then this will be cross product of these two, nothing but a plus b cross a minus b divided by modulus of a plus b cross a minus b. Now let us try to find one by one. This formula is going to make us understand what are the things we require. First we have to find a plus b, then a minus b, and take the cross product, then find the modulus of the same and substitute here. So vector a and b are here. First we want to find vector a plus vector b. What's vector a? 3 2 2. Okay, 3 I cap plus 2 j cap plus 2 k cap plus vector b. Vector b is here, I cap plus 2 j cap minus 2 k cap. How are we going to add into vector? I with I, j with j, and k with k. So here 3 plus, here I multiplies 1. So 3 plus 1 is 4. Then 2 plus 2 will be 4. Then 2 minus 2 will be 0 k cap. This is our vector a plus b. So vector a plus b we have got. What next we want? We want vector a minus b. Let us achieve that. Vector a minus b is equal to vector a, again 3 2 2. Then minus of vector b. Vector b is 1 2 minus 2. So I cap plus 2 j cap minus 2 k cap. When I say 1 2 minus 2, I am talking about scalar component. I multiplies 1, j multiplies 2, and k multiplies minus 2. Now let us simplify this. 3 I cap plus 2 j cap plus 2 k cap, minus the places minus I cap, minus the places minus 2 j cap. This is 2. Then minus minus is plus 2 k cap. So now let us simplify. How are you going to add or subtract two vectors? I with I, j with j, and k with k components. So here you see I multiple 3 and here it is minus 1. So 3 minus 1 will be 2. J multiple 2 and here it is minus 2. So 2 minus 2 will be 0 j cap. 2 plus 2 will be 4 k cap. This is our vector A minus B. Now what we have to get? We have to find the cross product of both. Okay, let's find it here. Let us find the cross product of vector A plus B and vector A minus B. It is determinant of I cap, J cap, K cap. Then the second row is component of first vector, that is A plus B. Component of A plus B is 4, 4, 0. 4, 4, 0. Then A minus B will be in the third row. Component is 2, 0, 4. So 2, 0, 4. Then plus, minus, plus. Let us expand this. So plus of I cap, leave the row and the column. So if I leave the first row and the first column, we are going to have 4, 0, 0, 4. Then minus J cap, leave the first row and second column, 4, 0, 2, 4. 4, 0, 2, 4. Then plus K cap, leave the first row and the third column, 4, 4, 2, 0. Now, so now, plus minus, plus minus, plus minus. So let's simplify this. 4 into 4, 16. 0 into 0, 0 with minus sign. Then minus J cap of 4 into 4 will be again 16. Then plus into minus, minus 2 into 0 is 0. Then plus K cap. 4 into 0 is 0. Then minus 4 into 2 is 8. So 16 minus 0 will be 16 with I cap. Then minus 16 J cap. And 0 minus 8 is minus 8. Minus plus is minus. So minus 8 K cap. And here we have got vector A plus B cross vector A minus B. Okay. So we have got cross of A plus B and A minus B. Now coming to the, again, what we want. I want mod of A plus B and A minus B. So modulus of vector A plus B cross vector A minus B is equal to square root of I multiple is 16, so 16 square, plus J multiple is minus 16, so minus 16 the whole square, K multiple is minus 8, so minus 8 the whole square. 16 square will be 256. Again 16 minus 16 square is 256. 8 square is 64. Okay, so let's simplify. 256 we have got 2 times, then 64. So this will be 10, 16, borrow 1, 5, 10, 16, 17, and then 2, 4, 5, yeah, 576. Root of 576. What is the root of 576? It is 24. Yes. So we have got magnitude of A plus B cross A minus B. What is the modulus of this? 24. This we will take as equation number 2 and this we will take as equation number 3. Okay. Now put equation number 2 and 3 back in 1. So if I put in 1, we are going to have what is the expression? A plus B cross A minus B divided by modulus of A plus B, A plus B cross A minus B is equal to the numerator value we have got here. Let us substitute, that is 16 I cap minus 16 J cap and minus 8 K cap divided by mod of this value is here 24. Now if you see numerator 24, numerator what is common? 8 is common. If I take 8 out, 8 2s are 16, again 8 2s are 16, then 8 1s are 8 divided by 24. So very clearly 8 1s are 8, 8 3s are 24. So we are going to have the final value to be 2 I cap, in final vector to be 2 I cap minus 2 J cap minus K cap whole divided by 3. So this is the unit vector perpendicular to a plus b and a minus b. Okay, actually there is one more unit vector negative of this. Okay, so every plane will have 2 unit vector. So this will be the solution. So with this is a 3 marker question, mind you. With this, all the problems are done. First, kindly make a note. Okay, dear students, let us move on to the last concept, Cauchy-Schwarz inequality. So what this says is dot product of A and B is always less or equal to modulus of A and B. Let us try to understand the proof of this. See carefully. We know that dot product is given by A dot B is equal to modulus of A into modulus of B into cos theta. Solve for cos. If I just cross multiply this, we are going to have A dot B divided by modulus of A into modulus of B less, okay, is equal to, I mean to say, is equal to cos theta. And don't forget cosine value, the range of cosine value, as we know, is between -1 to +1. So if I take mod of this, then A dot B divided by modulus of A modulus of B will be always less or equal to what? 1. So if I cross multiply, as cosine value maximum value is what? 1. So cross multiply, we are going to have A dot B is less or equal to mod of A into mod of B. Who knows, for 1 marker they may ask, and equality will hold if any one of the vector is 0. As mentioned, equality holds if either vector A is 0 vector or vector B is 0 vector. Okay, and one last in this note is triangle inequality. Let us just have the result, that is modulus of A plus B is less or equal to mod A plus mod B. This is triangle inequality. Triangle inequality. Okay, so with this we are done with the chapter. Just thought let you have this. Who knows, for 1 mark it will be useful. So with this we come to an end. So only 2 chapters are pending now, that is 3D and probability to be uploaded. So I hope so within this week I'm going to do so. So all the very best, study well, give 100%, be dedicated towards the studies, and give your 100% commitment towards your examination. So all the very best, and God bless you all. Do like, share and subscribe to our YouTube channel Math Universe with Dr. Naseer Ahmed. Thank you all.